Nuclear fusion is a process where two atomic nuclei come together and fuse to form a heavier nucleus, releasing a large amount of energy in the process. This is the same process that powers the Sun and other stars in the universe. In practical terms, scientists are working on harnessing this process as a source of energy on Earth. The idea is to use a controlled reaction to heat up and compress hydrogen gas until the nuclei fuse together, releasing a huge amount of energy in the form of heat and light. However, nuclear fusion is still a very challenging technology to develop, as it requires incredibly high temperatures and pressures to achieve the necessary conditions for fusion to occur. Scientists are working on experimental reactors to test the feasibility of fusion as an energy source, and while progress is being made, it may still be several decades before commercial fusion power plants become a reality. The potential of fusion energy is enormous. If it can be successfully harnessed, nuclear fusion has the potential to provide a virtually limitless source of clean, sustainable energy. Compared to traditional energy sources like fossil fuels, fusion energy has several advantages. First, it produces no greenhouse gases or other harmful pollutants, which could help address the growing problem of climate change. Second, the fuel used in nuclear fusion, hydrogen, is abundant and can be extracted from water, so there is no danger of running out of fuel. Finally, fusion energy has the potential to be much more efficient than traditional energy sources, with much higher energy outputs per unit of fuel. In addition, fusion energy could help address several other pressing energy-related challenges. For example, it could provide a source of energy for remote areas without access to traditional power grids, or help power electric cars and other vehicles. It could also help address the intermittent nature of renewable energy sources like solar and wind power by providing a constant source of energy that can be easily controlled. Overall, the potential of fusion energy is vast, but it is important to note that significant technological and engineering challenges remain before it can be deployed on a commercial scale. Nonetheless, with continued research and development, fusion energy could become a major contributor to the world's energy mix in the coming decades. There have been several recent nuclear fusion breakthroughs that have advanced our understanding of this promising technology. In 2021, the world's largest nuclear fusion reactor, ITER, achieved a major milestone by completing the assembly of its tokamak device. A tokamak is a device that uses a magnetic field to confine and control the hot plasma in which fusion occurs. The completion of the tokamak assembly represents a major step forward in the development of nuclear fusion as a viable source of energy. In addition, researchers at the University of Warwick in the UK announced a breakthrough in their work on a new type of nuclear fusion reactor. Their design, called a spherical tokamak, uses a much smaller and more compact tokamak device than traditional designs. This could make fusion reactors much cheaper and easier to build, while still achieving the high temperatures and pressures needed for fusion to occur. Another breakthrough came from researchers at the Max Planck Institute for Plasma Physics in Germany, who were able to sustain a fusion reaction for a record-breaking 6 minutes and 30 seconds. This was achieved using a device called a Wendelstein 7X stellarator, which uses a different type of magnetic field to control the plasma. While these breakthroughs are certainly exciting, it is important to note that nuclear fusion is still a technology in development, and it may be several decades before it becomes a viable source of energy on a commercial scale. Nonetheless, the progress being made in this field is very promising, and many scientists and engineers are working hard to make fusion power a reality.